Good morning, folks. As a recap of yesterday evening's class session and demonstration, I would like to repeat some of the key um, approaches or concepts in how, for example, now we can start reverse engineering or creating our design based on the 3D scan data 123D catch provided for us. Step one is, of course, you need to scale your object, your scan object, down into the correct dimension. You can see inside the world setting, or the scene setting, sorry, I went to units and set everything for imperial. You guys are very familiar with it, so that's the reason why I'm using it. And then on your object, your real object, for example, you can mark, let's say, a line being 1 inch long, and then create a mesh that is 1 inch long, and then use that as a reference. In my case, for example, I started to measure in this Black & Decker logo sticker because I know this is roughly 0.75 inches by 1.25 inches wide. So let's say this piece is the original scan. So of course it is too big. Somewhere I can just create this plane, press N, go to my transform properties, and scale it down. And then, for example, this should be 1.25 inch. And sorry, I was wrong. 1.25 inch, wrong axis. And oh yeah, I have to apply the rotation, of course. So X, sorry, 1.25 inch. I had my object rotated, which is why the values I put in were wrong, 1.25 inch. And Z 1.75 inch. There. Okay, so now you can see that this object is much smaller than, for example, my scan object. So for example, I can bring this one to here, position my 3D cursor at an edge, select my object, set the pivot point to 3D cursor, and then actually scale till it fits, kind of like this. And at this point, I would say probably my handrail has the correct dimension. So if I then press Ctrl A to apply the scale, or select the drill object and then apply scale. So now those dimensions are really reflecting the actual mesh data. There is in the new version of Blender also another interesting tool to measure distances. So if you go press T to open the toolbar, go to tool objects, object tools, sorry, and then go to ruler and protractor. If you click it, you will see up here like a small entry for the menu. Control left mouse button add, delete, remove, control drag, snap, etc., etc. So that means I can click and then drag out, for example, a measurement distance. Click with control left click, add another measurement. So for example, if I click on this end, see I can position those markers, maybe bad spot, and for example, measure everything. If, for example, you want to measure a degree also, if you click and then drag it out and then click actually on this number, there you can measure, for example, an angle. So for example, what's the angle of this surface? And if you press escape, you just leave the measurement tool. So this was basically step one. And then I tried to position everything so it sits on the X and Y plane. And honestly, it doesn't really matter where your object is, but of course, it makes sense to position your object in the world center so that when you start working on something, it's not feet or meters away from the ground plane. Okay, after this step, now we can think about how we start rebuilding the surface. Now, beginning of the semester, I mentioned don't get confused by the intricacy and details of objects or your sketches, but try to think methodologically how you could simplify design and step by step build up geometric primitives. And then after that is done, we start adding the details. So this means, for example, the battery pack is a very linear, boxy design. And I will demonstrate a certain way how to work on that and create it. The handle is actually very organic and sculpted. And the upper part is very tubular, like a cylinder. So think about, for example, foam modeling. The top part, I would use a block of foam, put it on a wood turn, and just wood turn this profile, and then end up basically with a nice cross section. The handle part, basically, I would take sandpaper and sand everything nice, soft, and round. And the battery pack, I basically could use nearly even the bandsaw and cut everything away, because very much those are linear cuts. So if you imagine how you have to do that with foam, this gives you then indicators in how you can actually build it in real life. So let's, for example, start with the upper part. You see here I have a line, and this line actually follows kind of like this internal axis, and it's slightly rotated. And I parented this model to this line, and you do this by, for example, selecting the object, selecting then your target, and then you can either go to object, parent, and object, or you can press Ctrl P, object. So this means if I now move this line, you see my power drill follows. Because this line is rotated 1.326 degrees, if I set this to 0, I rotate my complete mesh, and this one is now nicely lined up horizontally. The reason why I did this is simply it will make it easier for me now to start building the cylindrical profile. Also, this line is roughly in the center of my model as well, I think, pretty much, nearly. So, how do we start? Very simple. I can, for example, select this line, press Shift S, cursor to select it, and then Shift A, add a plane. And for example, this plane, I scale down. So for example, it hits the left and right part. I can add a loop cut in the center, so Control R, press Enter, and then those points I delete. The center edge I delete. So I end up just with this result. And then from a side view, for example, I can press R, and I have to type in -90 degrees. So you see, like, I framed it, and then those points I can move slightly down. And the whole point for this is simply I can now use this to start building in different features. So to subdivide, for example, this line, you can select an edge, go to mesh tools, and then where's subdivide there. And then it will add a point. And down here, for example, there are the subdivide options. For example, I can at the same time add maybe 3 cuts. So this point, for example, I move to here. This point I move to there. And then, for example, I start lining up these points to roughly block out the design. Maybe this one goes to there, down a little bit. Those actually I would like to be all at the same level. So I go to bounding box, scale as along the z-axis and 0. So they're safe. Between here, for example, I would like to have a subdivision of 2 points, because these 2 points then I push down S and X, move them apart. Perfect. And here, subdivide, move it over, bring it to there. I can also, for example, simply delete this part and then by hand simply extrude everything. So always just pressing E. Or build it, for example, this way. Works as well. Now the last part, and that's going to be a little bit tricky, is actually the rounded back part. So what I do here is I select this point, snap my 3D cursor to there, press Shift A, add a circle, maybe with 16 points. So you see, then I scale it down, rotate along the x-axis 90 degrees, scale it down, and for example, with B and then pressing middle mouse button, I deselect those points, X, delete those points. This one can go. And for example, move this one in, maybe to there. This one I move to there. Select those two, press F, fill. Okay. So this is pretty much how I quickly blocked out this profile. And again, if you build something for manufacturing, you might separate everything. But right now we're still building just a solid shell, because also the goal right now is to create something we can send to the rapid prototyper. So we have to simplify design a little bit. So it's not about being accurate in terms of how pieces later will be put into the injection mold, but more about how can we create a model that can be 3D printed, and at the same time then later gives us a flexibility to also create manufacturing models from it. So I added a subdivision surface modifier. And you see by doing this very rough polygon line got softened. Then, for example, I can add a skin modifier. Sorry, I meant a screw modifier. And I need to switch the axis to X. See, X-axis goes this way. Maybe 32 steps. And actually, hold on, I move this one up. So first screw, and then the resulted lathe tool I would like to clean up. Turn on calculate order. So maybe let's put this one to 6. So there it is. Doesn't look too bad. But there are a few problems. Everything is very soft now. And also I have like a pointy bit here. So the problem with the back is those two lines to the mirror axis, or the revolve or lathe axis, are not parallel. So I have to adjust this. I can easily do this by subdividing it and then maybe moving this one down. And then this one has to be at the same vertical line. So two ways how I can do it. I select both, Shift S, X, and 0, or I turn on vertex snap, click on the X arrow, and then Control, remove my left mouse button, and it snaps. I can move this one down if I want to work a little bit with the flat part. But this, for example, now looks a little bit better. Okay, so there is a small slight flatness to it, but I also know that the scan revealed that this back part is actually not really 100% round, but it's a little bit more squeezed, so like this. So I adjusted now all these points to craft a nice curvature. Okay, so in my scan object, I know that, for example, here are sharp edges, specifically when I take a look at the real object. So what I can do here, let me show you. If you select two edges or 2 points in an edge, you can press Y. And Y basically rips it out, so it separates it. So for example, this is a separate part. So Y, and here, for example, I have like a background image I brought in. So for example, it looks like this also is separate. And this is separate. Okay. There we are. But now we have to put in a little bit more details. So for example, those edges here are rounded. So I can go ahead, for example, select those 2 points, press W, subdivide, and then with selecting this point, pressing G and G, so 2 times, I switch into edge slide. And then, as you can see, I have a little bit more control in just moving this point along the edge, and make sure that, for example, I don't move the point up or down, but just along this ray. And actually, hold on. The design is actually built this way. For example, here we can do the same. So W, there was a problem. Now, if you want to make sure that, for example, those roundings are equal, you can go to N, go to Mesh Display, and then Edge Length. And for example, here you see 14.6 whatever, thousandths of an inch, and 15. So GG. Let's say, for example, I want to try to make this 14. And then with Shift, I can scale really in small steps. Like this. So this way, for example, you have a little bit more control over the roundings. So let's say this should be like there. So this was 14, yeah. Okay, so same then here, 14 and 14. Okay, I hope you start getting the idea. So it's not really very complicated. And here this edge is a little bit not too strong, so I keep it there. So in this way you could just continue refining everything. Now, for example, the block. I'm going to position my cursor and just create a cube. And I make the cube actually bigger. That's okay. Because again, think about what are you going to do inside the wood shop. You will start a cube, then you start drawing side profiles and front profiles, and then you go to the bandsaw and cut everything out. And yeah, we're basically going to do exactly the same. So let me put this one maybe to this layer. And with the bandsaw, you only have the ability to cut straight through your foam and also, for example, yeah, make a curve. But you can't really cut compound directions. But that's a great tool, or the great part about what I'm going to show you now, that we in a polygonal environment right now can work exactly the same how later we're going to work in Fusion or Alias by creating surfaces and then using those surfaces as, think about them as knives to cut through your foam block. So I create a plane, can scale it down a little bit, and I have to make the plane sufficiently bigger than the foam block. So this is really important. They should not stop inside. They should really cut through it. Again, think about them as knives. So I maybe bring this one over to here. And hold on. This piece actually has to be rotated. So I would like this along the y-axis, rotated. Perfect. Okay. So let's turn this one on for a second. So here, for example, I can see that to the front it seems to be flat, and then to the back there is an arc. So how can I try to do this? Very simple. I take this cube, I make a center loop cut, Control R, press enter, so I don't move this thing left and right. And for example, I add a subsurface modifier. Somewhere here, for example, it starts arcing down. This part is more flat, so I add a loop cut somewhere there. Yeah, maybe GX, move it to the right. And then, for example, maybe those outer points with G and Z, I simply move down. So I create a surface like this. Can smooth it. Maybe make it one step nicer. And if I want, maybe those midpoints, I move slightly up. So the top part is slightly arced. And no, this is a little bit too high, so I can move it down. And it looks like this one has to go down more. Yeah, like this. Okay, great. Now what's really important, again, try to work methodologically and start naming your stuff. For example, this one I call boolean new battery top. And I typed in new because I already have this whole system built once. And for example, this one I call battery pack new. Okay. So this one I give a boolean modifier. And then for example, I type in new boolean or boolean new battery. So, and that's again the really nice part about naming stuff. You can just type in a word and then you see it filters everything. I had something used with new. So for example, boolean new battery pack top. Okay. And difference or intersect, in this case, doesn't really matter. Let's for a second go to here, edit mode, say normals. So normals face upwards. I can, for example, flip the direction so they're facing inwards. So with the difference, basically, which just means it keeps the difference. So everything on the other side of where the normals are, that's being removed. And this is being kept. So perfect. Now you see, for example, up here, there's a front and a round part. So I can create another plane. Scale it down. Again, it just has to be bigger than the foam block. Then I rotate it, maybe move it to there. And maybe this one I call front top. And then I add another boolean modifier. Hold on. Yeah, okay. With new. So I type in new. See, that's my filter for all the new boolean surfaces. Couldn't execute. No, you should. Where's the problem? Let's see. So it all penetrates through it. Let's flip the direction. Let's show the normal. Okay. Oh, this is interesting. Well, let's try to figure out where the problem is. Oh, I used 2 times the same. Of course, that doesn't really work. Wah, wah. Top front. There. So, I used 2 times the same surface to cut the cube. Okay. Now the really nice part about this type of modeling is simply the flexibility you have, and that's why I love it so much. And the great part about Blender, in contrast to other commercial polygonal modelers like Modo, it has those interactive modifiers, and those are very similar to the parametric approach with NURB surfacing I will introduce you when, for example, we work with Alias or Fusion. But as precise as NURBS is, sometimes it is just a little bit slower. And when you really want to quickly to play through some ideas, this is actually a much faster and productive approach. So for example, right now I could add a subsurface modifier. Just make sure it really penetrates my form model. Go into edit mode, add a loop cut, select those 2 points, and maybe move those up a little bit. And then you see though that the form model adjusted to it. You might notice that right now it's a little bit difficult to judge your form model because you always have those meshes there. So 2 tricks to clean this up. First, with all these meshes in their modifier for subsurface, we turn on optimal display. Optimal display simplifies the mesh preview. And then you go to the object data, go to display and say wire and wire. So now we work with a wire representation, and all the time I can see what's happening inside. So terrific. This, for example, shows me this is too far. So now you see I can, this is so awesome. You can just move this part and you see like it shaves off that form block interactively. It's just beautiful. Okay, so there's a front part maybe I would like to trim off as well. So I could maybe duplicate this one, rotate it so it's minus 90 maybe, 0 and 0. Maybe move it to there. And actually, hold on. I Alt D, so I make a clone of this one. Move it to there. And the reason why I Alt D it is, for example, I call this one front. Front. Let's go to the foam block. Add another boolean. New front. Difference. The cool part is there's a certain curvature. See? This arc is the same as this arc. If I would like, for example, adjust this mesh, because it's a clone, it also adjusts the other mesh. And hold on, I have to actually make this one a little bit wider. There. So you see that because those 2 front faces are clones, if I modify one clone, it modifies the other clone, and I always get exactly the same curvatures cut out. For example, another great example for why to work with shared data. So let's bring this one into there. Let's bring in this one maybe to there. Perfect. So the back part is, for example, a little bit more tricky. So it has some curvature parts to it, and it has a cutout. So the cutout is actually really simple. So let me save. Just creating a cylinder, scale it down. Then I rotate it, scale it down further. In object mode, move it in edit mode, move the mesh apart. I can, for example, if I want to delete those faces. And then I call this one, for example, boolean new battery tool opening. Okay. And yeah, I have to make this one wider because you see it does not stick out. So edit mode, S and Y, and make it stick out. Okay. Shape smooth. And then add another boolean modifier. New. And there's tool opening and difference. So let's see. Okay, perfect. We can see through it. Great. So it's kind of awesome. Like if you move it up, see, just adjusts it. Also for this one, I would like a wire representation. Okay, next step. The back part. It's not too difficult. So, for example, I can, if I want to, shift D, duplicate this one, move it to here, then maybe 90 degrees, move it down. And actually, those points I delete. And then I have to plan a little bit in how maybe I can craft the shape. So I know on one side it arcs this way, and from a side it arcs this way. So selecting those side points, I can, for example, define this arc. And then I have to define also this arc. So maybe for the moment I put this one down, make a loop cut, move this one forward, and maybe Alt click on those edges, move those inwards. So that this mesh actually kind of like looks like this. And then let's see how this is actually going to work out. So let's call this one battery pack back. Select the cube, foam. You can, for example, also name those, for example, top, front, top. So you don't just have boolean point 0, 0, whatever. Front, front. For example, tool opening. So you see, if I collapse those, it's more logical. Another boolean modifier. Back, new, back, difference. Oh, what's happening here? Okay, let's see. What happens if I turn everything off? Still works that way. Let's see, my errors face all inside, okay. Oh yeah, okay. The reason why it didn't work was simply, and that's also something to keep in mind about orders. So, for example, those are all my different steps already applied. This surface sticks above, but here the lower part, it does not stick below. So I move it up, E and Z, move it down, so it really penetrates again. It has to be like a knife that goes completely through it. And let's turn it on, and bang, there it is. Perfect. See? Let's hide this part. There is everything so far. So that's pretty awesome. Maybe an edge modifier, an edge split, so you can see what we're doing a little bit better. And the great part is simply, again, speed. How quickly I can now, for example, select this center part, move it out, preview different ideas. And because I am trimming just a block, I'm not trimming complicated subdivision surface models, I have a low amount of polygons to work with, and that makes Blender calculating everything insanely fast. So for example, with moving this part now, I could adjust how far, for example, I have this opening there. See? It's just beautiful. Okay. Maybe we have to get a plane on the bottom. So I move it down to where maybe the bottom part is, like there. And maybe call this one bottom. To copy, for example, also multiple settings. For example, here, hold on, before I do this, I'm going to create another plane, rotate it maybe like this, move it to the right side, scale it down to there, move it over there. And then you see my object center is all perfectly at the x-axis. I'm going to use a mirror modifier along the y-axis. So when, for example, I adjust this, I work on the other side at the same time. Let's call this one sides. Now I can select those two objects, select this one, go to the object properties, go to wire, and then I press right click and say copy to selected, which means Blender copies this wire setting to the other two objects I had selected. Okay, so maybe this one, no, let's add two more modifiers. For example, this is bottom and sides. So different side new. Oops, that's the wrong direction. So maybe I have to flip, yeah, the normal. And there's something else interesting happening. So let's figure out what that is just in a second. And let's go to the bottom one. Bottom new. Difference. Okay, well, this is interesting. Let's see. Oh, maybe the edge split should have been the last step. And sides, yeah, there. So you saw that with the edge split, for example, being up, it can confuse the software because again, this is kind of like a design tree, step by step by step. You have to work through everything. And yeah, so here's basically now, for example, a very fast preliminary idea in how to design this shape. And for example, we also have this battery pack here. So this battery pack, hold on, I want to clean up something first. So all these lines, for example, I move to a different layer. Okay, so this battery pack, for example, I create by, how do we do this? Yeah, let's do it that way. Create the cylinder, scale it down. Then from here, I rotate it. Scale it down more. Maybe move it up a little bit. And then I move this one to the right. Shift D, move it to the other side. And then, for example, I delete half of those parts. And then I select those points, fill those. Nope. And scale it out. Okay. Let me move this one to this layer, because I really have to make sure that actually properly it sits on the bottom part and doesn't stick out too much. So the easiest way to do this is I have to bring in my bottom plane, and I think with snap to vertex. Yeah, so see, I move it down, so the lowest vertex snaps to this vertex. So this is fine. Okay, great. Shade smooth. And I'm going to help myself. This, for example, tells me that my battery pack is actually too small. So here, those faces, for example, I move inwards more. See, now it lines up with this. And now I would like to have something similar, basically, that cuts it this way. So I duplicate this mesh, go into edit mode, SY and 0, so they're straight, and then maybe move them out to there. For example, sides 2. And for example, here I create another boolean, sides 2, difference. Oh, this battery pack I think is not white enough. There. See, now this white shell is being trimmed by this other shell. So now this, for example, is solid. And now I see, for example, here there's something sticking through from the other object. So maybe this battery pack, I move over a little bit to the right, so it doesn't perfectly stick in. Great. And then maybe just to help the software, just notch it down just a notch. And then, for example, I can join both together. So this, for example, I call is battery lower part. So this object, I go boolean, move the edge split down, union battery lower part. And didn't work. What's going on? Let's undo the different steps and see where the problem actually is. So let's give this an edge split. there. Maybe I made some sort of a mistake. And this battery pack, for example, I can move up and down. So you see like it's being joined to the part. And actually, I would like this one to go onto this layer here, because in here, I just want to have this as a result. So you see, that was actually not really very difficult. And again, last but not least, another demo in the beauty of this process. So I'm just removing some of these lines because they're confusing maybe a little bit too much. I can now go ahead and really easily, for example, play with those shells, or maybe I want this to be a subsurface. So for example, I gave this edge a slight roundness. And again, all those sharp edges later we actually change in a different software like Fusion, and also the transition between, for example, this main object and the battery pack. So for example, also here. So this all can be changed later. And that inside your design process, for example, would be the last feature to add to your CAD model. But where you really will spend a lot of time is just starting blocking out the surfaces for cutting like this design out of your form block or digital form block. Let's save this. Okay, so let's see where we are in our time. I'm going to make a stop here and then start another recording where then I will show you how to. Oh no, I will just leave it inside here. So let's take basically a look maybe at the handle. Handle looks complicated, but again, it is very, very simple. It's basically a tubular object that goes up. And there are two ways how we can start with a cube, and then we have to subdivide the cube, or we just start right away with a ring. And just to make sure, for example, my 3D cursor is misplaced, so I select a reference object, Shift S, cursor to selected, and then maybe from the side now I can place my cursor to here, because you see, based on the view, you can only move your cursor in certain positions. So right now Z and X, but not along the Y-axis. And then Shift A, circle. And I would like to have 1, 2, 3, 4, 5, 6. So a circle with 6 vertices. Maybe rotate along the Z-axis 90 degrees. So I have for example, left and right those points. Then I can add a subdivision surface modifier. Maybe from here scale it down a little bit more and try to position it. And I can do this quickly in object mode for the moment, that's fine. Maybe scale along the X, no, scale along the Y axis. The Z rotation and the scale is adjusted, so Control A, apply scale and rotation. And then maybe let's start trying to craft the first part. So I go into edit mode, select everything, E and Z, and for example, move it up. And then I can see if it, for example, fits in or not. and maybe another, or wait, actually, I move this one to here and then show you how, for example, I would continue working. So there's a very interesting command called shear. So I press spacebar, type in shear, and then where my mouse is, like in the status bar, you see press X or Y for the axis. So right now you don't really see anything because it shears along the x-axis. As I press Y and move my mouse up and down, you see actually how it shears it. And it's not really rotating, it's basically moving each point proportionally up and down. So for example, I will try to do it this way, because what I want is maybe to have a match to this. Okay, maybe scale it down a notch, add a loop cut here. Maybe this loop cut I scale a little bit, so you see that I'm kind of like giving it a nice curvature. And then comes the tricky part. Now, how do I make the transition to go over to there? And there are certain ways how we can maybe do this. I press E, move this one up, S and Z, and kind of like go to maybe somewhere there. And now I have to play around a little bit. I need some geometry here to build, for example, this part. So I can select all those points, press E, and move it to the right. I might have to do some cleanups because you see by the extrusion I added an internal surface. Those points maybe I would like to move up, maybe a little bit to there, and see how this looks. Maybe this one can go up. There. So you see like how it started to move out. But for example, here you see that I'm missing my scan data, so I have to adjust this a little bit more. So for example, everything here, I move till there it sticks out. Great. And then this whole part maybe has to move up. And maybe, yeah, maybe this point I have to move to there. Maybe this one I rotate a little bit. Okay. Now the same trick or problem I have in the front part. And pay close attention to the way how sometimes things look like, because actually I am extremely sure that they built it this way. It was just an object like this, and then they created a surface to cut this space out. So I will try to use the same method. So I select my front faces here, E, move it to the right over. There's this top face I have to delete. And then C. Yeah. And this is very round there. Maybe at that point I would like to add a loop cut and move this one down, so I can straighten the upper surface and then have a rounding. And at this point, actually, to be honest, because I started with a 6 vertex circle, I can simply delete 1/2, because it's easier to just work on one model, 1/2 only, and then start, for example, sculpting everything. So for example, I know that the front part is more narrow. So these points, for example, I push in. So you see now this gets a little bit more narrow. And maybe up here I need to have another loop cut to tighten this corner a little bit. And maybe here those I move up a little bit more so that I have nice curves. And a nice flow. Okay, it's getting close. Maybe this lower part can be scaled along the x-axis. Maybe this part push out a little bit, rotate slightly. Okay, and as I said, here they have something cut out. So then there again, let's add a plane. Make sure the plane is centered. Then I move this plane maybe, I don't know, doesn't really matter, to here or so. And then in edit mode, I try to sculpt this a little bit, maybe a loop cut up here. Let's show my object. Then I add a subdivision surface modifier, shade smooth, okay. And for example, this one I call boolean new trigger. And maybe let's make this one wire. Okay, then for this handle, boolean. Let's see which, there's the trigger, difference. And let's add an edge split. Perfect, see? There we have now the space cut out for our handle. And then I can, for example, try to adjust this a little bit more, like in edit mode. Maybe I move this one up. And then, for example, use my scan data to maybe try to see where I'm getting close to the way how it should be. So that seems to be very close to it. Let me show you one nice trick. So it's also about ergonomics and how it feels. So I create a center line, and then maybe those points here, I have to play with this a little bit. Actually, not this one. I move backwards. So you see that this cutout gets a slight curve, because your finger will go around, and maybe you want those transitions to be nice. There. Okay. Now to build, for example, the trigger button itself, that's very simple. Right click, position the 3D cursor, add a cube, scale the cube down, maybe a little bit bigger. Then, for example, add a subsurface to select everything, shade smooth. I delete this edge. So I just have kind of like this shell. Now, front view, I can scale it till it has the width I need. And then in relationship to my rebuild object, I can, for example, move this one in more. And now I would like this to be a little bit more ergonomic, so there should be kind of like a convex shape for my finger. So 3 loop cuts, central loop cut, for example, move in, upper loop cut moves up, lower loop cut moves down, for example. Also, this is rounded. If you want this to be more flat, maybe 2 loop cuts. And then we have to scale everything, of course. But I hope you get the idea how quickly you can sculpt and play with those different ideas, and then quite quickly come up with interesting kind of configurations or designs. Okay, so this I think rounds up basically how I created most of my designs in my first attempt to build kind of like my hand drill. And you see, for example, here I have separate objects. And then again, I just used the boolean modifier together with those drill elements. And let me give you one last example for how to do this again. So you don't want to have multiple Boolean operations always applied on the same object. So because those in real life also are separate elements, I'm going to break them down as well. So I know, for example, that I pressed L on this part, so I selected only these points, and then I separate it. Okay, so now it's a separate object. This I hide. And for example, this one I call drill front. Now you need to do a little bit of counting to see how many of those points you have there, and let's see if maybe even the scan data is somewhat usable. It provides a little bit of a reference. So let's see, the 3 cursor is still positioned at the same position, so I again start, for example, with a cube, scale it down, move this cube, and now this is a really important step to remember. So this object has, where's this one positioned? Z, kind of like there. So I select everything, copy or Control C, paste it into this object. Copy V. Oh, wah, wah. Apple C, Apple V. So slightly moved it up. Then I can move it maybe inside and, for example, move it up. Make a very simple cube. And maybe from the side, maybe rotate it a little bit so it's parallel to that surface, kind of like this. And then from here, I have to adjust it, and maybe again the scan data could be helpful to get an idea for the proportion. I mean, you could also measure it. Feels like this. So now you have in the real object, of course, you have to count how many are there. So let me see how many I used. So it's a count of 12. Let me separate everything. So this one should get an array modifier. No relative offset, count of 12. And again, it's really, really important. Think about this as a lathe. We want this to rotate around a certain point. So this means um, the object center has to be the center this one will rotate around. So the mesh has to be away from the object center. Where the object center is, I press Shift S to place my insert marker, and then I place an empty. I do not scale the empty, but I just by hand inside the empty property change the size maybe to 1 inch. This is really important because now I have 12. So let's see, 360 degree by 12 makes 30-degree steps. So this one along the x-axis, I can say rotate by 30 degrees. And I name this object, for example, empty array drill front. I go to this part, and then I say to the modifier object offset. I can, for example, type in empty drill front. Gadung, there it is. Perfect. And I think in the real object, it arcs a little bit, so maybe right here I make a loop cut, Shift S, snap my cursor, set my pivot point to there, and then slightly rotate it. Okay. Great. So, before I do any crazy subdivision surface stuff, I leave it at first at this boxy part because all I want is just to figure out if this will work out. So for example, this one now I call boolean drill, I know, let's say new drill front. Okay. And I move this one back to 6, to there. So this part is invisible. So you see, like my construction geometry I have somewhere else, and my final piece I have on a different layer. And now I can add a boolean modifier, type in drill and drill new front. I think that's this one, yes. And difference. And there it is. See, perfect. Because I work with a low polygon amount, I can easily, for example, select all these points or select everything and simply move it up, hide it, preview it, Alt H, edit mode, move the mesh more inwards, H, preview it. So you see the speed is just fantastic. And then if I want at that point to have nicer rounded edges, if I want to, I could go add a subsurface modifier, not too much, just 2 or something, shade smooth, maybe make 2 loop cuts, enter, maybe 2 loop cuts, enter, maybe here I add a loop cut to the end to sharpen that rounding, hide, edit. Okay, great. And then edge split. Perfect. See? If you end up with some interesting artifacts while you have the edge split, sometimes you have to work with the degrees. So what does this edge split actually mean? Very simple. Let me create 2 planes. And let's move this one up. So for example, here, this is 90 degrees. So from here to there, see, 90. And the edge split basically says when, for example, something is from 0 to 10 degrees. Let's see. It's rounding everything. If it's, for example, 0 to 20 degrees, 0 to 90 degrees, it starts to, how could I say that? The higher the degree, the more the software tries to soften everything. So for example, you see those edges look soft, but they are rather sharp. So that's the reason why you get these artifacts. If we set this to 0, for example, you see all the facets. And if maybe I go to 10, you see the outside actually looks good because the degrees are really minimal, but you can see inside it's all faceted. So maybe 20. It's not working enough. See, there's still some sharp lines. 25. Yeah, it's getting close. 30. Yeah. It's not really an ideal situation in all cases because those edges are sharp, the inside is good, but this is slightly rendered like with an artifact. But again, it's not really a big problem. It's not the geometry is bad, it's just a visual representation. And yeah, so that was basically everything I wanted to demonstrate to you for next class in how, for example, you have to, again, think about the geometrical basic objects. Can you use the screw command? For example, for that part, can you use like surface cuttings in a foam block, or where, for example, we work on the handle. Oh, where's my handle? Oh, my handle is here. Which then is more traditional clay sculpting without using a screw modifier or subdivision boolean modifiers. But then again, for certain very specific cutouts, then we can make use of those boolean modifiers and surfaces, because the really nice part about this process, again, and I can't stress it enough, the beauty of Blender is simply because you have subdivision surface modifiers and boolean modifiers. Those are interactive, which means like in computer-aided design, that's parametric. You can always adjust them without having to rebuild everything. In all these surfaces, we would, for example, bring into Fusion, turn those polygon surfaces into T-spline, which is a different technology, and then the T-spline we will convert into NURBS surfaces, and then instead of Boolean modifying, we will use trim commands, which is kind of like a scissor. So we start cutting all the surfaces. So we as well just end up, for example, with this. And then with a NURBS feature, we can round those edges. So it's all about the process and trying to not do the most complex stuff at the beginning, step by step, work through easy steps, and really try to be efficient how you spend your time. For example, like here, use a very fast, not 100% correct, but very fast visual approach to sculpting, because afterwards we can still then reuse the geometry we created and just then finish the model correctly.